Our next speaker is Subrayan, who is going to be telling us about an extensive TOM for the time domain era, SAGUARO, as a scalable discovery platform.
All right.
Thank you.
Okay. All right. Good morning, everyone. Thank you for making it to the final day of the conference. I'm Subrayan. I'm a postdoc at University of Arizona. First of all, let me also take the opportunity to thank the organizers for giving this platform to showcase our cool work that we have been doing. Today, I'll be talking about, or I'll be introducing you to SAGUARO, which is a target and observation manager. So this is going to be a little bit more of an infrastructure talk and how we are using SAGUARO as an extensible target and observation manager for hotwiring the time domain era. Before I start, I want to give a huge shout out to this incredible collaboration. You can see there are people in the crowd who are also in the slide. So a huge shout out to this collaboration. This is an incredible team effort of what we are building for the time domain era. And if you are interested in any of the things that I'm going to talk today, please come find us and we will be happy to chat more about the collaboration as well as about what we are building into. So what is SAGUARO? You might be confused that if you look at the acronym, it is searches after gravitational waves using Arizona observatories. But why is it in a supernova session? But my job is to tell you that something that we have already built for doing some gravitational follow-up, we are using that to enable much more time domain discoveries. And I will, by the end of the talk, I will try to convince you that TOMs are very cool and they can be used for multiple science cases, and you can use TOMs for building the science case that you want and following up transients from there. So at its core, SAGUARO is a coordinated network of Arizona telescopes. You can see that we are leveraging the facilities for gravitational follow-up using Arizona observatories, which is the 1.5 meter Catalina Sky Survey telescope, as well as we are using it for follow-up using bigger telescopes with like MMT as well as LBT. So for gravitational wave follow-up, we all know that wide field of view is required for searching electromagnetic counterparts for them. So we leverage the capabilities of the Catalina Sky Survey. Basically, we are trying to repurpose asteroid search survey to use for gravitational wave follow-up. So what it provides us is with wide field of view. It provides us with calibrated images. It provides with reasonable depth for searching these gravitational wave counterparts. And I will talk more about how we are incorporating it to the inner system and how we use it actually for gravitational wave follow-up. So, but from a hardwiring perspective, from an infrastructure perspective, what really is SAGUARO in a front end? So it is a Django-based web application. We have heard earlier talks from Dan, who talked about goats, and we will be in the further future sessions. We'll be also talking. We'll be listening to infrastructure talks from Curtis and Andy about how TOM is used for as a marshal or as a target and observation manager for different time domain cases. So for me, when I think about TOM, it is one place where you can integrate multiple tools together for the science that you want to. So for the specific gravitational wave follow-up, we have multiple things that come together for identifying the viable potential candidates for follow-up, as well as for following them up. And I'll show that in a minute. So let me walk you through a workflow of how we do GW follow-up, and I promise I'll tell you at the end of the talk how we are going to do follow-up from the candidates that Dave talked about with shadowing. But let me just start you with making you understand or giving you a tour of how TOM works for gravitational wave follow-up and how we are extending it to multiple other science cases. So on a day, we are bombarded with Slack alerts. So we ingest all these gravitational wave alerts using SIMA hopscotch that Gautam talked about. And then how it comes to us are these big Slack messages in channels where we are just, hey, there's an exciting binary neutron star event or neutron star black hole event. In this case, this is a subsolar mass event, which was heavily talked about in this conference. So these come to us with all the information available with different links where we can get the situational awareness of what the gravitational wave event is about and what we want to do after when we get an event or alert like this. So yes, we are notified that we have this exciting event going on. Now with a click, we are able to submit whatever localization is there. We are able to ingest those localization maps, and we are able to make optimized tiling strategies that can be submitted to the CSS scheduler that I talked about in just a click. So this, when you click the submit button, what it does is that it overwrites the normal CSS schedule, and it is prioritizing the gravitational wave fields that is in the localization maps, and then you can take the observations for searching for the electromagnetic counterparts. Here I am showing the next step where we are the white fields that the white fields that you're seeing here is the tiling or the tiles that are already observed with CSS, and we submit this to the treasure map where the community can also coordinate to see where what localization regions are being already observed and prevent duplicative efforts. We also ingest TNS in an hourly basis to see what other candidates are being put forward by the community, and then we try to get a situational awareness of what the best candidates are, as Griffin alluded in his talk, and I'll also talk about in a minute. So at the end of the day, what we get back is we have a web page where we scan all these candidates and we rank them based on machine learning metrics. We have the stamps based on the image processing subtraction pipeline that we do. So we have all the information available coherently in one place. And we vet for these candidates. And I will tell you in a minute how easy it is to do that from a web-based TOM, where you can gather all the information about the candidates that are coming to you from these observations. So you can see here, this is an example of a candidate where you can get all the information at one place. You have these point source matches, you have these Atlas force photometry that you can run with all these facilities that you have. You can get the distances to these candidates based on cross-matching with catalogs. So here is an example where you can easily rule out something which is for a gravitational wave event perspective, because you can see that there are pre-merger detections, and then you can easily rule them out. But let me show you a better candidate what we can get the information about. So here is a candidate which was reported for this SSM event from the community. So you can see that in the web form itself, you can have associations and point source matches. And once you just click the button of vet there, you can actually cross-match it with catalogs that are available to get a sense of the localization, to get a sense of the distance. And if it matches the GW distance, and you can actually make it or rank the candidates based on this one. So target observation managers in that sense are very cool, where you can have every information, all the information about the target in one place. Here I'm showing that if you are interested in a candidate and the candidate gets to be a potential candidate, you can actually submit follow-up spectroscopy. Here you can see that there is a cool MMT, PyMMT package that Manisha developed, where you can, from the TOM itself, you can submit follow-up spectroscopy, not just with MMT, but like we can incorporate multiple observatories like LCO, SOAR to submit for the future observations or follow-up observations. Here I'm showing where you can, how easy it is from the TOM itself. You can report things. And this is important because if we are doing community follow-up, we should make everybody aware about what candidates we are following up. And Griffin talked about this in his talk about where we are building tools to rank and vet these candidates and score them so that we can give the community a perspective of what are the best candidates that we can follow up in this situation. So it is easy to report and classify or submit your classification to TNS just from the same coherent web page of the target, and you can make the community aware about that. Now, I talked about GW follow-up, great. I want to talk or emphasize about how can it be used for the science cases that you are interested in. And it is very relevant because Rubin started streaming alerts and how we are preparing for the Rubin era and as well as for the Roman era. And I will talk about that in a few sentences about that too. So here we are ingesting actively the LSST alerts via the Antares broker. We have active filters, which is going on. And this is the initial testing phases where on day 1, February 25th, I was giving another talk. LSST started streaming. And we are actively ingesting those alerts into our system. And within the first day, because everything is coherent, we are able to see these targets. We're able to see if they are really real. We submitted almost 10 AT reports of possible supernovae on the same day, on the first day. We were actually scrolling through our Slack alerts. We were looking at the TOM. We were looking at SAGUARO. We were looking at these targets. And we were finding real things on the first day of LSST alerts. And these alerts, of the ones that we reported, there was one which was actually 2 of them which were followed up. So here is an example of how we ingest LSST alerts. We are seeing that in our TOM. So here is a supernova where you can see that these LSST alerts in all the bands, we ingest them through Antares. So you can actually see the Antares ID. You can actually see the point source matches. And eventually, after, the community is also listening and paying attention to these transits that we're reporting, and that's been followed up. And it is a supernova 1 at the red 0.96. So this is showing the capability of having all the information at one place from multiple streams together, and how we can maximize the information on one given target. Because it's a target observation manager, this can be extended to any target of your interest, not just TW targets, not just supernovas target, but the LCO has built an amazing COM toolkit package where you can actually use that for your own particular science case. So Dave talked about our mission of finding young, early supernovae in the era of LSST, and how we are having a shadow program with DECAM, where we are using LSST as a discovery for these, but at the same time, to get the earliest and high cadence observations, we're shadowing them with DECAM. So in my next few slides, I am going to talk about how we are using the same TOM infrastructure to look and find candidates that we are seeing from the DECAM observations. So this is from the observations from DECAM, and thanks to the collaborators, we are using the CMU pipeline. So here are examples of different images and the candidates we're ingesting every night of DECAM observations. And all of this is automated. On a night, there is a DECAM observations, there is a cron job running, we get these candidates and we can scan through these candidates, and we can actually report them or find them and cross-match them with any known supernova. So we are actually finding supernova that are already reported to TNS. This is an example of where we are finding very, we are having deep observations. Actually, you can see those magnitudes are very deep and relevant for DECAM, but with LSST and DECAM pooling in together, we are able to find very young and early observations of these young nearby supernovae, especially in these nearby galaxy clusters that Dave talked about. Oops, back. Just let me, oops. Oh, now I have to. Anyway, this keeps on looping it. Anyway, but what I wanted to emphasize is that this is just one other science case that I demonstrated where we are using it for finding young and nearby supernova, but clearly, TOMs are very flexible. TOMs are very modular. They can be used for any kind of science case that you want. This could be used for other non-localized events like neutrino follow-up, or even for Roman. If we are planning to ingest the rapid alerts, we will need to build the infrastructure, understanding the alert packets, and we will be able to ingest them and again, get all the information together in one place. So I'll just leave that slide. I did not realize that this is okay. I am over time, but thank you for your patience and listening. I will just put this slide up and just emphasize that TOMs are really cool and you can use them for your particular science case. Come talk to us if you want to understand how we build these tools. Thank you.
Questions for Badia? Mansi?
Very nice, Bhagya. The question I have for you is on the last couple of slides, you were showing the DECAM stream. Are you actually sending these to TNS, like everything you see from DECAM?
not everything, the things that we think are real, we are actually reporting it. Let me-
Because I would love to know, because ZTF is shadowing, right? There must be some overlap. So if there are any, things that even before LSST starts.
Yeah, I think,
Things
yes,
fine.
we are, let me just see. Yeah, we are actually sending things to, or reporting things to TNS. There is overlap. I think if we are ingesting Antares alerts and we are finding things from ZTF, we are actually cross-matching it with our candidates. So we will definitely know if there was a CTF event. Actually, I don't know if I have an example. I can actually show you this. We have actually cross-matched things that are from ZTF. Which at least for the initial early alerts, we are doing the M49, which is the Virgo fields, at least because LSST has been sparse, but ZTF is observing those. We are cross-matching them with the candidates that we are finding from that. That's true.
Okay, any other quick questions? I know it might mess up the acronym, but any plans to go beyond Arizona?
Any plans for?
Go beyond Arizona for telescopes?
We are open. Yeah, I think so. Yeah, 100%. We actually submit a follow-up proposal with the Stewart telescopes, but we are more than open to expand it to different cases and different facilities. 100%.
Okay, let's think about that again.
Thank you.